Chapter 10, Lesson 2 is measuring angles and arcs. We have 4 vocabulary terms that we're going to focus on today, the first being a central angle. A central angle is an angle whose vertex is at the center of the circle. So this is an example of a central angle. Notice the vertex of our angle AOC is at the center of the circle. And the sides are radii of the circle. So segment AO and segment CO are each a radius of the circle. Now, the key here for a central angle, and it's not necessarily given to you in the reading, says the measure of a central angle is equal to the measure of the intercepted arc. What that means, notice my angle AOC is 65 degrees, and a whole circle is 360 degrees. Well, the portion of the arc that's between your angle, we call this an intercepted arc, and this is arc AC, is also going to be 65 degrees. Okay. There are 3 types of arcs. We have minor arcs, major arcs, and semicircles. Okay, here's a picture of a circle with angle ACB. And ACB is a central angle. A minor arc is an arc with a measure less than 180 degrees. Okay? So an example in this picture of a minor arc is arc AB. And arc AB is the arc that goes from point A, the shortest distance, to point B. A major arc is an arc with a measure greater than 180 degrees. So here's an example, arc ADB. So it goes from point A through D and around to B. So we have to follow the order of the letters. Minor arcs, we only use 2 letters. Major arcs tend to be named with 3 letters. Now, if it goes through more than 3 letters, that's fine, but we only list 3, the first and the last being the 2 endpoints. And a semicircle is an arc that measures 180 degrees. So if you have a semicircle, that means the endpoints of the arc have to fall on the diameter of the circle. So notice segment FG is the diameter. It's a chord that passes through the center. Well, a semicircle has to have a starting point and an ending point for the arc that are the endpoints of the diameter. So an example of a semicircle is arc FHG. A semicircle can have either 2 letters or 3 letters. Okay. Now, our first big idea is the sum of the central angles. Okay, the sum of the measures of the central angles of a circle is 360 degrees. Okay. Each of these angles, angles 1, 2, and 3, are central angles, which means they have the same measure of the intercepted arc. And if you go all the way around a circle, it is 360 degrees. I'm not sure why I just put 180, but the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 360 degrees. Okay. Now let's turn the page and look at example 1. We need to find the value of x. Now this circle is comprised of 4 central angles, and using the sum of the central angles, we know all of those have to add up to 360 degrees. So we would take 40 degrees plus 90 plus x plus 85 is equal to 360 degrees. And I would solve this for x. So on the left side, I'm going to combine like terms. I have 40 plus 90 plus 85 is 215. So I have x plus 215 is equal to 360 degrees. I subtract 215 from both sides. So 360 minus 215, and the value of x is 145 degrees. Okay, if we look at letter B, Okay, letter B is different because each central angle is an expression. So I have an unknown value of x. But notice I also do not know the value of t. So I need to find something else that I am familiar with. Now, I see that segment RV is a diameter. If segment RV is a diameter, then I know that arc RV is a semicircle and adds up to 180 degrees. Okay, so I know that the three angles on the right half have to add up to 180. So I know that 8x minus 4 plus 13x minus 3 plus 5x plus 5 adds up to be 180 degrees. Okay, I'm going to combine like terms, starting with the terms containing an x. I have 8 plus 13 plus 5, that's 26. So 26x. Now I'm going to combine the numbers, the constants. Negative 4 plus negative 3 plus 5 is negative 2. This is all equal to 180 degrees. I can add 2 on both sides. So 26x is equal to 182 degrees. Divide both sides by 26. And x is equal to 7. Okay, example 2 says segment AC and segment DB are diameters of circle with center Q. Identify each arc as a major arc, minor arc, or semicircle of the circle. Then find its measure. Now the first thing I'm going to do before I begin is fill in the value of each angle measure. Okay, so I'm given that segment AC is a diameter, which means arc ABC is a semicircle and is 180 degrees. So if I take 180 degrees minus 100 degrees, then angle AQB has to be 80 degrees. And I know that vertical angles are congruent, so this angle is also 80 degrees. Now, since AC is a diameter, that means the top half of the circle is also a semicircle. So these three angles have to add up to 180. So I'm going to take 180 minus 80 minus 50, and angle EQE has to be 50 degrees. I'm just going to write this so that it's a little clearer. This was 80. Now I know the arcs are the same measure as the central angle. So beginning with arc AE, so from A to E is right here. The arc is equal to the central angle, so the measure of that arc is 50 degrees. Since 50 degrees is less than 180, arc AE is a minor arc. Okay, next I have arc AB. Here's arc AB. The arc is equal to the measure of the central angle. So arc AB is 80 degrees. Since 80 degrees is less than 180, arc AB is a minor arc. Next, I have arc EDC. Make this a little larger. So arc E to D to C comes around here and is comprised of two central angles. So I have to add together my 50-degree angle and my 80-degree angle. Okay, this is an example of arc addition. It's adding two arcs to get the whole. So 50 degrees plus 80 degrees is 130 degrees. And since 130 degrees is less than 180, this is also a minor arc. Next, I have arc ADC. So A has to go through D, has to go through C. That is half of the circle. So comprised of 3 central angles, so I'm going to add 50 plus 50 plus 80 degrees. Add those together, and arc ADC is 180 degrees. This represents a semicircle. Okay, next I have arc ABC. So from A to B to C is comprised of 2 central angles, 80 degrees and 100 degrees. Add those two together, arc ABC is 180 degrees. This represents a semicircle. Last, I have arc BC. Okay, here's B to C. The central angle is 100 degrees, so arc BC is also 100 degrees. 100 degrees is less than 180 degrees, so this also represents a minor arc. Okay, I would like for you to try example 4 on your own. Example 4 says segment FH and segment EG are diameters of circle with center P. Find each measure. Okay. When you are finished, I would like for you to click on the link to check your answer, and then you're going to play the second video to look at example 5.